This question looks interesting. Let's have a look. A circle C1 is given to you. This is your circle. Of course, the radius is root 3, center is origin. It says that it intersects this parabola at the point P in the first quadrant. So let's have the circle and also the point quickly. So this is a small circle with radius root 3. And can we get that point P, the intersection of this circle and the parabola? X square is 2y. So instead of x square, I'm going to write 2y. Okay. Can you solve this? Okay, this is minus 3 is equal to 0. So if you solve, what do you get? You get y plus 3 and y minus 1 is 0. You get two values for y. One is 1 and the other is minus 3. You will not take the negative because x square can't be negative. You are taking y value to be 1. So you get x to be root 2. Positive root 2 because they are looking for a point P in the positive quadrant. Okay, so this is your point P with x coordinate root 2 and y coordinate 1. It's the intersection point of the circle and the this parabola. Let's read more. Let the tangent to the circle C1 at P touches other two circles C2 and C3 at R2 and R3. So too many points. Let's read the full thing respectively. Suppose C2 and C3 have radii equal to 2 root 3 and the centers are Q2 and Q3. If Q2, Q3 lies on y-axis, then which one is 2? So digest all the information which they have given you. First of all, they're talking about the tangent. So let's draw the tangent first. So tangent at P. Okay, it is touching two other circles. Okay, the same tangent is touching two other circles, C2 and C3. What kind of circles? So this radius you know is root 3. They are giving that the radii are both the same, 2 root 3. Okay, of course, it's a double of this one, right? So you have to go somewhere further because they're also saying that the center of the circle is on the y-axis. Okay, so let's say that here. Okay, let's draw a radii. Okay, of course, it will be tangent, right? And let's say this is the center. Center they're saying is Q2. Okay, for the one circle. So let's call this Q2. And the point which it is touching, that's R2. Okay, you can complete the circle if you want. Okay, I will just do a little bit of it like that. Okay, this is a circle, you can complete this up. Okay. Similarly, the same radii. Okay, let's say you have somewhere here because center has to be on the y-axis, so maybe I will draw center somewhere here. Okay, and the radii is again 2 root 3. So this point I can say is what? Q3. No, R, right? They're touching at R2, R3. So this is R3 and the center is Q3. Okay, you if you want again you can complete the circle up. Okay, because this is the center and this is the point where it is touching, so something like that. So finally your figure is ready. Now let's see what they're saying. Okay, Q2, Q3. Okay, so how do I get Q2, Q3? Okay, one thing is for sure that Q3, Q2, Q3 both are on what? Y-axis. Okay, so if I assume some coordinate, it would be how? Like x is 0, right? And y coordinate I can assume anything. Let's call it alpha. Okay. Secondly, the foremost thing what we can do is we can write equation of this tangent like R2, R3. Okay, R2P, R3, that's a tangent, right? So quickly write equation of tangent. So tangent to this circle at point P. Okay, write it down. X1. Okay, x1. X1 is root 2. Plus y1. Y1 is 1. This is equal to 3. Very simple. You got equation of the tangent. Okay. Now, what do I do? See, from here you are dropping a perpendicular to the tangent, right? Now you got the tangent root 2x plus y is 3. Okay. You see? So from Q3, okay, you drop a perpendicular to the tangent. Okay, tangent, I will write the equation of the tangent to this. I will do minus 3 is equal to 0. So length of the tangent, what is it? The radius. Okay, 2 root 3. This is equal to modulus of, you know the formula, Q3 we have assumed is 0 alpha. Instead of x you are going to write as 0. Root 2 times 0 plus y you are replacing by alpha. The formula, the perpendicular from a point to the line, upon under root a square plus b square. Root 2 square, that's 2, plus 1. Y coefficient is 1. Okay, so how much do you get? You get alpha minus 3 is upon root 3. That's 2 root 3. Now, of course, when you remove the modulus, you get with a plus and minus. So let's write that down. So you are getting this is equal to plus or minus 2 root 3. This is plus root 3. And with the minus, you get this. Okay. So let's solve it up. So you're getting alpha minus 3 is equal to 2 times 3, that's 6, plus 3, that's 9. Okay, so alpha is 9. You got alpha to be 9. And here, how much you're getting alpha? Again, this is minus 6 and plus 3, minus 3. Okay, so we got two values for alpha, that is minus 3 and 9. Why are we getting two values? One is for this, right, q3, and the other is for q2. Okay, that coordinate would be 0 and 9, because both the points are satisfying the same thing. Like from here we are dropping the perpendicular on the same line, and the radius is also the same. So same equation is getting followed even had you drop the perpendicular from q2. Correct? So we got this point. So now can you get me what is q2, q3? q2 you know, q3 you know, this distance, right? This distance is 9 and then plus 3. 9 plus 3 is 12. Yes. Okay, so A is very obvious. That's correct. Okay. Now look at the next one. What are they asking? R2, R3. Where is that? Okay, this is R2 and this is R3. I want to get the distance. See, one thing you can always do, you can figure out what's the coordinate of R2 and then what's the coordinate of R3. Use your distance formula. Okay, but that will be too long to do. Okay, we have to be a little bit more like intelligent here. What we can do is, you see, that you can use the fact that you already know what is your q2, q3. Okay, you already know that. So what I can do is, see, all the three radii are parallel, right? This and this, everyone is parallel because they all are perpendicular to the tangent r2, r3. I can extend this. Okay, let me extend, let me use some other color. Okay, I will extend this 2 root 3 on the other side. Okay, you see, now if I join this, okay, what is this point? Call it something, let's call it q2 prime. Now do you think that q2, q2 prime, that would be same as r2, r3? Just check. Okay, you have drawn a parallel. Okay, this is also 2 root 3. Okay, equal distance on the other side. Okay, and you have connected this up because now this is parallel to the tangent line. Okay, why we did that? Because we have completed a right angle triangle q2, q2 prime, q3. Just check. Okay, q2, q2 prime, and q3. What is the advantage? You know everything except this, right? You can get what is q2, q2 prime. Let's get that. So q2, q2 prime, okay, that would be under root 12 square minus 4 root 3 whole square. Okay, this whole thing, this is 12. Okay, 12 square minus this is 4 root 3. Okay, 4 root 3 whole square, you get that number. Okay, so how much is that? If you want, you can take 4 square out, that will be 4 outside the under root. This will be 9 and this will be 3. Okay, so you get 4 root 6, and that's what they're saying here. R2, r3 is 4 root 6. That's absolutely correct. Okay, and this is the same, which just now said, right? This is the same as r2, r3. That's why we said that this is correct. Okay, now let's work with the C part. Okay, it says that area of the triangle OR2, R3. Okay, so where is that? This is O. Okay, and R2 is here. Let's complete that up. R2, sorry, OR2, R3. Okay, this triangle they are talking about. Okay, what's the area? What's the area of the triangle? Triangle OR2, R3. Half times base times sides. Okay, let's do that. Half times base. Okay, how much is the base? R2, R3 is the base. Just now we got R2, R3 is 4 root 6. Okay, base times height. How much is height? You see that this radius vector is height. Radius is always perpendicular to the tangent. Okay, so how much is that? Root 3, right? Yeah. So we get 2 root 18. Okay, how much is that? 18 will be 9 times 2. Okay, so 6 root 2. Okay, so this option is also a correct option, that area of the triangle or r2, r3 is 6 root 3. Let's work with pq2, q3. Okay, let's work with triangle pq2, q3. Let's work with this. Where is that? Where is my p? This p. Pq2. Where is my q2? This, right? pq2, and where is q3? This is q3. Okay, this triangle we have to work with. Okay, now what is the base of this triangle? Q2, q3 is the base. Okay, so half times q2, q3 is the base. And what's the height of this triangle? It's just the this coordinate, right? Root 2, the x coordinate of p, root 2. So let's write root 2. Okay, so q2, q3, we already, the very first thing we did was getting q2, q3. So we are getting that this value is 6 root 2 again. Okay, and what are they saying? That it is 4 root 2. Okay, so this is not a correct option. So a little involved diagram you have. Okay, once you get that right, I think you will be there. Okay, see you with another question.